In the last video, I provided the intuition behind the concept of a relation. In this video, we're going to delve into a more mathematical definition of the concept. To define a relation, we first specify two sets. Let's call them A and B. A relation R from A to B is a subset of the Cartesian product between A and B. So R is a relation from A to B. So R is a subset of the Cartesian product between A and B, and what that means is that the set R is a set of ordered pairs, where for every ordered pair AB, that is an element of R, the first coordinate is an element of A, and the second coordinate is an element of B. And so if AB is an element of R, we say that A is related to B. So A is related to B based on this relation. And we use the notation ARB to represent this idea. So when we write ARB, this is the same thing as the ordered pair AB being a member of the set R, and that this also means A is related to B. And then we use this notation to represent this idea. And if AB is not an element of R, then we use the notation AR with a slash across the R, and then AR slash B to represent the idea that A is not related to B. Now that we're familiar with the notation, let's take a look at a concrete example. Let's suppose A to be the set consisting of the elements X and Y, and let's say B is the set consisting of the elements 1 and 2. And now let's define our relation R to be this set. Let's define R to be the set consisting of the ordered pairs x1, x2, and y1. Now for this particular relation, you can see that, first of all, x1 is an element of R. And so that means x is related to 1, and so we can write xr1. So this means x is related to 1 based on this relation. Also, on the other hand, you can see that y is not related to 2 because y2 is not an element of R. And so because of this, we can now write y r slash 2. And so this means y is not related to 2. Now let's take a look at two extreme examples. So we know that a relation R is a subset of A cross B. And also we know that the empty set is a subset of A cross B. We know this because I proved this previously, that the null set is a subset of any other set. And we also know that A cross B is a subset of A cross B. And this is also true because any set is always a subset of itself. And so therefore the empty set and A cross B are also relations from A to B. And if our relation is the null set, then this is a relation where no elements from A to B are related. And on the other hand, if our relation is A cross B, then this is the other extreme case where all the elements are related to each other. So these are two extreme cases you can consider. So far we've been dealing with the case where A and B are distinct sets, so A and B are distinct. However, it is also possible to define a relation from A to itself. In that case, your relation R would be a collection of ordered pairs where the first and second coordinates both belong to A. And then we call such a relation on set A. So a relation from A to A is a relation on set A. And as you might have already guessed, such a relation would be a subset of the Cartesian product between A and itself. Now before I end this video, I just want to point out one last thing. So far we've been dealing with relations between two sets, and this is what we call a binary relation. It is actually also possible to extend this concept to n-ary relations. And for such a relation, your relation R would be a collection of n tuples. And you can contrast this with binary relations. So for our binary relations, our relations are actually collections of two tuples. So for every single tuple that you see over here, they all contain two objects. Now for an n tuple, you would get a tuple that contains n objects. But binary relations are by far the most common type of relation that you will encounter. So in my videos, I will be focusing exclusively on binary relations.